Now we'll learn about the degree of differential equation. So degree of differential equation is what? This is the differential equation, order is 2. We'll say that degree of that differential equation is 1 because the power of highest order derivative occurring in the differential equation is 1. So this is 1, that is highest order derivative is 2, and its order is 1, so degree is equals to 1. Here highest order derivative is 1, and higher the power of highest order derivative is 2, so degree equals 2. So the power of highest order derivative occurring in the differential equation is called the degree of that differential equation. So we have done with degree of differential equation. Now we'll learn about linear differential equation. Linear differential equation, right? So linear differential equation. So we'll talk about linear differential equation. A linear differential equation that can be written in the form a linear differential equation is a differential equation that can be written in the form of a naught y to the power n plus a1 y to the power n minus 1 plus dot 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 a n minus 1 y dash plus a naught a n y is equals to qx, where so if a differential equation can be written in that form, then it is called linear differential equation. That is we can say a linear differential equation has no terms containing so 1 multiplication of y and its derivative, right? That is dependent variable and its derivative does not occur. That is, say example, dy dx d2y dx2 plus y of dy dx is equal to qx. Is not a linear differential equation, as y and y dash are multiplied together. So that's what important, right? Because y dash, that is y dot y dash, and we say that y and its multiplication cannot be exist. Y and its multiple derivative cannot be exist. So what is ai? Is ai are function of x, right? This is important to know that, right? Here ai's are function of x, so that's what is important, right? So that's the basic one, and that is so now we'll come across with a non-linear differential equation, right? Differential equation. So what is non-linear differential equation? A differential equation which is not linear, which is not linear is called non-linear differential equation. So example, example y dash plus y dash plus y equal to x, because what we can say that y and y dash are multiplied together, are multiplied together. So another example is y into y dash square, y into y dash of square plus y is equal to x square, because this term says that this is not a linear differential equation, right? So that's what is important to note that, right? So now we'll learn about the some solutions and formation of differential equation, how to form a differential equation. So formation of differential equation, say we are given a function, f of x, y, and c1, c2 up to cn is equals to 0. Then by differentiating n times, differentiating n times, we can get a differential equation, right? Because look, n constants are there, so n constants are there, and to remove the n constants we have to differentiate this n times, right? Because maximum of n times, because it may be possible that cn x to the power n contains, right? So if this term is contained, then after differentiating nth time we can remove that constant, right? So it is important to differentiate n times. So from here we can get a solution of the form f of xy y dash dot y to the power n x is equals to 0. So what we can say is from here is that an nth degree differential equation contains n arbitrary constant, right? So from here we can conclude that an nth degree differential equation contains n arbitrary constant, that is c1, c2, cn. So if degree is n plus 1, then number of arbitrary constant is n. So from here we can reverse the process, that is, if we have a differential equation, then we can certainly get the solution of the form this will be the solution of the form. If we have a differential equation of the form, then this solution will be of the form this, where the number of constant is n. So from this we can say that solution of differential equation, that means solution of differential equation, right? Solution of differential equation, that means a differential equation of the form f of x, y dash dot y to the power n is equals to 0 has solution of the form of the form I can say f of x phi x, say phi dash x, right? Phi to the power n x, that means is equals to 0. Phi x satisfy the differential equation with respect to x, the differential equation called integral curves. Then a real or complex value of a real value is the solution of the differential. Then this phi x is real or complex valued function, function of x, right? Real valued function of x. The differential equation is this. The solution of differential equation are called integral curves, right? The solution of the differential equation are called integral curves. So that's what is important. That means nth degree, we can say note important. It is important to note that, and nth degree differential equation contains an arbitrary constant. So that's what is important to note, is this, right? Thank you. We'll learn what we're going to learn all the course of differential equation, that is revision with all the, that is what we are going to do here. We will learn these topics, all these topics, differential equation, and all questions which came in GATE and NET, right, within 18 to 19 2021, right? So that's what our aim is, this, to complete these things on by 18 by 19, right? So that's important. That's what important for us. With, so introduction, we have done introduction, singular solution. So that's almost is we're going to learn. Then we'll go to the singular solution, general theory of linear differential equation of higher order, and so on. There are 7 topics you can see, right? So that's what is important for us, right? So that's all about for today. That is first one, sorry, second one, right?